Hello, Year 8. Over the next couple of lessons in standard form, we are going to be looking at how a number is written in standard form and how we can interchange between numbers written in standard form and what we consider our ordinary set of numbers. So if you can manage to print out the sheet today, that would be great. If you can't, then just copy this all down under your title and your objective. Standard form is a way of expressing really large or really small numbers in a slightly different way. Obviously, one of the issues with writing out incredibly large numbers, say 100 billion, is it would take quite a long time. Other restrictions with incredibly large numbers, and this is might be where you've seen standard form before, is if you type something into your calculator and the numbers get incredibly large, your calculator display has only got a limited number of digits, and if it goes beyond those number of digits, then it needs a different way of presenting that value to you, and that is when standard form is used. Now, a number in standard form always looks like this, with an A times 10 to the power of a certain number. Now, what's important is the value of A is always between 1 and 10. The times 10 is always going to be there. And the N, the power, just gives you a bit of an indicator of how large your number is going to be. So I'm just going to write that down. So A is always between 1 and 10. If we're being really technical, it can be 1, it can't be 10. And this value of n just gives you an indication of how big your number is. So I'm just going to put gives an idea of how large the value is. So what we're going to be focusing on today is if I write a number in standard form, can you write that back as an ordinary number? So let's have a look at a few questions and see how this works. So to begin with, in all of our examples, we are going to look at positive powers. So where the value of n is a positive integer. Okay? So it might be 2, it might be 3. Realistically, in standard form, you could be looking at even larger numbers than this. Now, the way that this works, well, we know what 3 is. 3 is just 3. And I would hope that you would know that 10 squared, 10 to the power 2, is 10 times 10. And 10 times 10 is 100. And we know what 3 times 100 is. So, that number, 3 times 10 to the power of 2, which is written in standard form, is the ordinary number 300. Let's look at this next one. Well, we've got 5 times 10 cubed, or 5 times 10 to the power of 3. Well, 10 to the power of 3 is 10 times 10 times 10. And that one is 1,000. And 5 times 1,000 is 5,000. So, 5 times 10 to the power of 3, written in standard form, as an ordinary number is 5,000. Let's try one with a decimal. Notice this number is still between 1 and 10. So I've got 6.7 times 10 to the 4. And 10 to the power of 4 is 10,000. So 6.7 times 10,000 So we need to move the digits 1, 2, 3, 4 places, is going to be 67,000. Finally, let's finish with 3.8 times 10 to the 3. 3.8 times 10 to the 3, well, 10 to the 3 we've already done, it's 1,000. So that 3.8 times 1,000, moving it 3 places, is 3,800. Now, I'm sure that one or two of you have already seen a little bit of a connection between this number and what we are multiplying by and what the implications of that are. And we'll talk a little bit more about that after some slightly harder examples. So we're now going to look at what happens with negative powers. Now, we did really actually do some work on negative powers and powers of 10 right at the start of the year, but it's likely that you're not going to perhaps remember that. So I will talk you through these, and then we'll talk about perhaps an easier way that one or two of you might want to think about this. Okay, so it's the same sort of idea, 5 times 10 to the negative 2. But what is a negative power? Okay, well, a negative power is a reciprocal, and I'm just going to explain that up here. So, for example, if I had 10 to the power of minus 1, a reciprocal is just 1 over that value. Okay, so it'd be 1 over 10. Or you might even think of that as 0.1. So 10 to the power of minus 1 is 0.1. Similarly, if I did a 10 to the power of minus 2, that is 1 over 10 squared, or 1 over 100, which is 0.01. So in this example, we are taking 5 and we are timesing it by 0.01. And that's actually equivalent to dividing by 100. So you could actually think, if you prefer, instead of it being times by 0.01, you could think of it as being divided by 100. And 5 divided by 100 is 0.05. So 5 times 10 to the negative 2 is 0.05, written as an ordinary number. So similarly, if we have a look at 7 times 10 to the negative 3, this is the same as 7 divided by what, do you think? 10 to the negative 2 was 100, 10 to the negative 3 is 1,000. And when you divide by 1,000, you are moving your digits 3 places. So that one becomes 0.007. And finally, 2.9 times 10 to the minus 1 is the same as 2.9 divided by 10. And that is 0.29. So, let's talk again about this relationship with the powers. What I've said here at the bottom, you can think of n as the number of place value positions you need to move this number. Okay, so for example, if we just go back to the previous slide, when I was multiplying by 10 to the power of 2, the 3, which was in the units column, has moved 2 place values to the left and is now in the hundreds. When it was power 3, the number has moved 3 place values to the left and has become 5,000. Similarly with the negative powers, you're just moving the opposite direction. So you are moving 2 to the right. The number is getting smaller. So what you might find is when you're doing some questions for me, you don't actually need to show me this calculation, because you look at that power. If it's positive, you know the number is going to be a big number, so move the digits to the left. If it is negative, you know it's going to be a small number, so move the digits to the right. Make sure when you're doing the questions for me that you write the original number in standard form and what it equals as an ordinary number. Of course, I will be providing the answers for you. So once you've finished, or your hour is up, or almost your hour is up, do take time to check your answers before sharing that with me. So good luck with this year 8. Get in touch if you have any problems. And that's me signing out. Take care. Goodbye.